Look around you. Every skyscraper, every vehicle, every piece of technology, all built by human hands. But what if I told you the greatest engineer isn't human at all? It doesn't speak. It doesn't write code. Yet it's been solving problems longer than any civilization in history. This engineer is nature. Imagine designing buildings that cool themselves like termite mounds, planes that fly like birds, robots that think like ants. This isn't the future. It's happening now. Welcome to the world of biomimicry, where nature's 3.8 billion years of genius becomes the blueprint for our most advanced technologies. What is biomimicry? Biomimicry sounds like science fiction, right? But it's not. It's real, and it's transforming the way we design, build, and innovate. The word itself comes from Greek, bios, meaning life, and mimesis, meaning to imitate. So biomimicry means to imitate life. But this isn't just copying how a leaf looks, or making something that flies like a bird. It's deeper, much deeper. Biomimicry means looking at how life functions, how it survives, evolves, and thrives. And then using those ideas to solve our own human challenges. Think about this. Nature has been solving problems for 3.8 billion years. Every thorn on a rose, every drop of dew on a beetle's back, every ripple in a fish's scales, none of it is random. These are solutions shaped by time, tested by evolution, and perfected for survival. A spider's silk is stronger than steel. A lotus leaf repels water and dirt like magic. Termite mounds regulate temperature better than our best buildings. And we're just beginning to understand how to learn from it all. Biomimicry invites us to stop seeing nature as a warehouse of raw materials, and instead to see it as a library of genius ideas. Because why reinvent the wheel when nature already made a better one? Let's start with one of the tiniest and most impressive engineers of nature, the honeybee. A bee's hive is more than a home. It's a masterpiece of collective intelligence, communication, and geometry. The hexagonal pattern of the hive, it's the most efficient way to use space and store resources. This inspired architects to create more stable and efficient building designs. But bees do more than build. They communicate using a dance language. This waggle dance inspired engineers to design algorithms for swarm robotics, delivery route optimizations, and even drone coordination. Birds, planes, and the flight revolution. When the Wright brothers designed the first airplane, they didn't study engines. They studied birds. The shape of wings, the way feathers adjust mid-flight, even the hollow structure of bird bones. Today's aircraft, especially high-efficiency models, use design principles straight from nature. Airbus and Boeing invest millions into biomimetic research. One prototype even copied the wingtip flexibility of eagles to reduce fuel consumption. The cheetah and speed engineering. Nature is also fast. The cheetah can go from 0 to 60 miles per hour in under 3 seconds. It's not just the speed, it's the balance, grip, and spine flexibility. Engineers studied these principles to design high-speed trains and running robots. One Japanese train had a problem. It was too loud when exiting tunnels. The solution? They copied the shape of a kingfisher's beak, a bird that dives into water with barely a splash. The result? A quieter, faster, and more energy-efficient train. We are living at a defining moment in human history. Our planet is under pressure like never before. Climate change is intensifying. Energy resources are being depleted, and the waste we produce is choking ecosystems around the globe. But what if the solutions we've been desperately searching for have been quietly surrounding us all along? Nature, with its 3.8 billion years of experience, has already faced and overcome these very challenges. No blueprints, no pollution, just pure, elegant, sustainable design. Take the termite, for instance. In the scorching heat of the African savanna, termites build mounds that stay cool inside without a single watt of electricity. Inspired by this, architects around the world have designed buildings that regulate temperature naturally, without air conditioning, reducing both energy use and environmental impact. Or look at the skin of a shark. Its microscopic patterns prevent bacteria from attaching and multiplying. Engineers replicated this design to create bacteria-resistant surfaces for hospitals, saving lives without relying on toxic chemicals. Even the lotus leaf holds secrets. Its surface causes water and dirt to roll off effortlessly. This inspired the creation of self-cleaning glass, now used in skyscrapers and solar panels, minimizing maintenance and maximizing efficiency. Now, imagine cities that function like forests, cleaning the air, filtering water, creating energy, and nurturing life. Imagine machines that collaborate like ants, think like octopuses, and adapt like living ecosystems. This isn't science fiction. This is biomimicry. It's not just about creating new technologies. It's about rethinking the very way we innovate. Instead of dominating nature, we learn from it. Instead of producing waste, we design for regeneration. Biomimicry invites us to build a future that is not only sustainable, but intelligent, beautiful, and deeply connected to the world around us. This is more than a method. It's a movement, a new lens to see the world, a new path forward for humanity and for life itself. The future belongs to those who listen to nature. Nature is not a resource to be exploited. It is a library of genius, a partner, a guide. The greatest minds of the 21st century won't just be inventors, they'll be listeners. Listeners to the silence of a leaf, the precision of an insect, the logic of the forest. Biomimicry isn't about going backward. It's about moving forward, guided by the intelligence that's always been here. The future isn't man-made, it's nature-inspired.